Going over the Java solution for Leetcode 746, min cost climbing stairs. You are given an integer array cost where cost I is the cost of the ith step on a staircase. Once you pay the cost, you can either jump 1 or 2 steps. You can either start from the step with index 0 or the step with index 1, return the minimum cost to reach the top of the floor. So in example 1, you're basically going to either start at 10 or index 0 or 15 or index 1, and then you're trying to reach this end of the array or beyond the last element. So whenever you land on any one of these, you're going to have to pay the fine, and then you can jump either 1 or 2 steps forward. So in this case, the optimal way to minimize cost is to start at index 15 and then jump 2 to get out of there. With example 2, instead of starting at index 2, which would get you closer, it costs 100, so you would instead start at index 1. And then you would jump 2, jump 2, jump 2, jump 1, and then jump 2, and then jump 1 or 2 to get out. This way you avoided all the hundreds and basically optimized for the minimum cost. So this problem is a really good introductory problem to dynamic programming and greedy algorithms. So dynamic programming is basically breaking apart a large problem into smaller subsets and then figuring out the optimal solution for each, and basically scaling your way up to the larger problem. And with greedy algorithms, it's basically taking in the short-term gain, basically the choice that is the most beneficial in the short term without considering long-term implications. So let's implement this. Basically, the idea here is that we're going to make a separate array that keeps track of how much it costs to reach each element. So this sort of has a bit of dynamic programming into it. So instead of saying, okay, what is the minimum cost for this entire array, we can say, what is the minimum cost to reach this element? And in that case, that would be basically the minimum cost between 1 or 100. Since we had to start on either one of these, then we could just jump to this one. So in that case, it would be this one, and then we would jump to this one. So we could put in a 2 here, since 1 plus 1 would equal 2. Then, if we wanted to figure out what is the minimum cost to reach this index, then we can say, what is the minimum cost between 100 and this element, which we updated to a 2. And in that case, it would still be this 2. So we can change this into a 3. So basically, the minimum cost to reach this index is 3. Then if we wanted to reach this index, it's basically, what is the minimum cost between 2 and 3? And that we're going to pick 2. So this will turn into a 3. And it's basically just keeping track of how much it costs to reach each index, and we're going to use that information in the future to help educate our guesses. So in terms of dynamic programming, we're basically breaking it apart into smaller problems, and in terms of greedy algorithms, we're just choosing whichever one is the shortest between the last two. So let's implement that. Let's make a new array. That will be cost.length. And basically this array will keep track of how much it costs to reach each index of cost. So if a cost was only made up of one index, and let's say we had to step on at least one, the cost to reach index 0 would be the cost of that index, and then the cost to reach index 1 would be the cost of that index. And now we can actually start a loop. So now the next index is going to be the math.min of basically cost I, so how much it costs there, plus array of I minus 1, so how much it costs to get basically, for example, in this element, how much it costs to reach this, it's basically the minimum cost between either 100 or 1. So we can say that cost I plus array I minus 2. So for example, if we reached this index, so this I think we said would be cost 2, since you could go 1 and then this one, so it would become 2. So now we're seeing what is less, either 1 plus 2 or 1 plus 100. Whichever one it is, that's what we're going to update this as. So that's going to become the minimum cost to reach this index. So we can just do that, and then at the very end, we can just return the minimum between array.length minus 1 and array array.length minus 2. So since it's the whole idea that we don't need to reach the last element, if we are one element behind it, we could jump 2 to get out, or if we are at the last element, like in this one, we can just jump 1 to get out. We're just going to pick the minimum between these two. So that should be it. Let's see if it works. Okay, great. And let's submit it. Okay, great. So that was most min